हेलो एवरीवन, वेलकम टू आवर चैनल केमिस्ट्री एकेडमी फॉर IIT JEE एंड नीट। हमने कुछ दिन पहले IOQC 2021 का एक क्वेश्चन डिस्कस किया था, जिसका फीडबैक काफी अच्छा आया एंड आई रिसीव्ड सो मेनी मेल्स रिगार्डिंग सम मोर क्वेश्चंस इन दैट पर्टिकुलर सीरीज। आज हम उसमें सेकंड क्वेश्चन डिस्कस करने जा रहे हैं। InCHO 2014 का 25 मार्क्स का एक क्वेश्चन जो बेसिकली अमीन्स की केमिस्ट्री और कायरलिटी पर बेस्ड है। आज हम इसी को डिस्कस करने जा रहे हैं। This particular question is of 25 marks and is quite lengthy as it has 15 parts in it. So we'll discuss these 15 into 3 different episodes. This is our first episode. So we'll discuss first 5 today in episode number 1. Let's first see the question. Alkaloids are naturally occurring nitrogen heterocycles. Although they are poisonous, when used in very small quantities, they have medicinal value as well. Alkaloid A, molecular formula is given as C17H23NO3 on hydrolysis with barium hydroxide yields two products B, C9H10O3 and C8H15NO. So instead of moving to the complete question at this time, we have used the question on each individual page also. So we'll move directly. If anyone wants to read full question, I am giving a little pause at every page. You can pause the video and see the question. 14 and 50. Compound B. Now we have already mentioned that we have to remember the formula of compound B, which is given to be C9H10 O3 does not add bromine and it dissolves in NHCO3. Heating B strongly yields compound D, molecular formula C9H8O2. Based on these observations, which of the following statement is or are true for compound B? So we have to select amongst these 4 statements which is true. So first let us interpret the informations. As the question mentioned that B does not add bromine, so it cannot be an olefin. That is, it cannot have alkene in it. So as a result, I can say that this cannot be the answer. B is an olefin, cannot be the answer. Next, it dissolves in NHCO3 solution, so it must be a carboxylic acid because this is the characteristic reaction of carboxylic acid. They react with NHCO3 solution. It is directly to be interpreted that yes, it is having a carboxyl group. So this box is going to be correct. Next, so let's calculate degree of unsaturation of B, right? Formula is already given. So degree of unsaturation formula is C is number of carbon atoms plus 1 minus hydrogen atoms plus halogen atoms minus nitrogen, this part upon 2. And we have to neglect any bivalent atom like oxygen and sulfur. They are considered to be non-existent for this formula. So here, see, the formula for B was C9H10O3. So degree of unsaturation is 9 plus 1 minus 10. This 10 is count of hydrogen plus 0 minus 0. Solving this, we are getting degree of unsaturation to be 5. As degree of unsaturation is 5, it simply means that there is a lot of unsaturation in the molecule, so it must be any aromatic compound. On strong heating, it loses water, so it can have alcoholic group. We cannot deny. So the correct statement are A, C, and D. See, this was 1.5 marks. So if you would have ticked all 3 correct, you would have got 1.5. Moving 3.2. Now this question says compound D on oxidation gives benzoic acid as one of the products. Based on this observation, the possible structures for compound D is or are. Now see, benzoic acid is to be formed when it is formed whenever with benzene you have a carbon having, if it is an alkyl, then either this or it is CH2R or it is CH3. In all these conditions, it will form benzoic acid on oxidation. There are so many different, so let me just give you a general idea. If it has a double bond like this, yes, it will form. If it has a PHC triple bond CH, it will form. If it has a secondary alcohol linkage, primary alcohol linkage, 3-degree alcohol linkage at this junction, this benzylic carbon has any degree of alcohol. It could be 1 degree, it could be 2 degree, or it could be 3 degree. Then also it will be formed. If it has ketone, there is, yes, possibility of benzoic acid to be formed. So many possibilities that, yes, I can have a benzoic acid. The main point, benzene should have only one substituent attached to it. Only when it is sp3 hybridized alkyl, then it should have H attached to it. If it is sp2 or sp, then you don't need H. For example, in case of sp2, even if you have this, then first it will form ketone, and then after ketone it will go to benzoic acid. So maintaining this, let us read the question again. Compound T on oxidation give benzoic acid as one of the product. Based on the observation, the possible structure for compound T is or R. So yes, this is a possibility. Going to B, yes, it can also form the required benzoic acid. Similarly, yes, C also can form because it is basically PHCH2 CH2 COOH. So this can also form benzoic acid. Now, when you have three options, your second stage has to be maintaining that this chemical formula is followed or not, because it has already been said that D is having certain molecular formula. It has been said in the question. So C9H8O2. If we'll check this molecular formula, option D will be removed from the answer, and we are left with only A and B as our answers. Let's move to next subpart, number third. Now third is a reaction question. Let us read. It says compound B has been synthesized by following reaction sequence. Draw the structure of the intermediate E to H and the structure of B. Okay, you have to draw the intermediates from E to H also, and the final product B, which has been initially mentioned. Product H is also obtained on treatment of G with HBr in presence of peroxide. So HBr in presence of peroxide is an example of anti-Markovnikov of addition of HBr. We'll see what is its importance. So let's start. First, it is said that this PHCOCH3, I have drawn it like this, on addition of HCN. So this is a reaction of cyanohydrin addition on aldehydes and ketones. Is a very common reaction. This cyanide will attack on this particular carbonyl, and as a result, this pi bond of carbonyl will open. So I have given you this product, PHCCH3OHCN. This is your E. On hydrolysis of this E, the cyanide part will undergo hydrolysis, and here we'll have COH instead of CN. Now we'll have COH. This is our compound F. Now it is said that this F is heated in a reduced pressure. Okay, it is heated under reduced pressure. So number of molecules should increase on the reaction instead of decreasing. Now see, this particular F is a alpha hydroxy carboxylic acid. So there are two possibilities of reaction with alpha hydroxy carboxylic acid. One possibility is on heating that it loses water molecules like this and can have a dimerized structure, something called lactone. But as you can see that if I talk of this lactone formation, this thing, then the number of molecules in a reaction are decreasing. From 2, it will become 1. But as it is said that the pressure is low, so under reduced pressure, it should be increasing. So this molecule, instead of this pathway, will go to this reaction in which it loses water, it dehydrates. So from 1 molecule, you are getting 2 molecules. This particular is G. This G has been asked in a similar way in 2021. Yes, this particular has been asked in 2021. Now see, when HBr from G to H, when we are moving, they are adding HBr. So now here students may get confused that what should we do? Should we go for stability of a benzylic carbocation and thereby forming a Markovnikov addition, or should we form what I wrote as anti-Markovnikov? So let me tell you, bachcho, whenever you have electron withdrawing group directly attached to this double bond, directly attached to sp2 carbon, directly, and this should be very strong. This G should be very strong electron withdrawing group like nitro, like cyano, like COOH, etc. Then you can have this type of reaction. or else what will happen is you will still continue to have Markovnikov. If it would have been just one more carbon ahead, see, for example, if the whole arrangement was like this, a little more away from our designated carbon, then this again will follow Markovnikov additions and you will have negative part added here, whereas in this negative part added here. Coming back to the question which is asked as G here, as electron withdrawing G is directly attached to our sp2 carbon, so you will have anti-Markovnikov addition and H, bromine, is attached on least substituted carbon. And it has also mentioned in the question that H is also obtained on treatment of G with HBr in peroxide. So we are in sync with the information. Till here it is perfectly correct. Now it is said that they are adding aqueous NaOH. So we'll simply have this bromine change to OH. This reaction is going to be SN2 and the structure of B is now available. So let me decrease the size so that you can have it all on one screen. See, first addition of HCN, then hydrolysis of CN to COH, then dehydration. From G to H it is addition of HBr but by anti-Markovnikov mode, and then aqueous NaOH SN2. Bromine is displaced with OH. So this was part 3.3. Let's move to 3.4. But before that, some information was given. We have to read that and interpret that. Structure elucidation of an alkaloid makes use of several chemical and physical methods. One of them is the Hoffman's exhaustive methylation method for determining the nature of the nitrogen heterocyclic ring. The heterocyclic ring is opened up with loss of nitrogen as an amine and formation of the less substituted olefin. If less substituted olefin is being mentioned, it means Hoffman products will be formed. And the reaction they are saying is a Hoffman exhaustive methylation. I'll explain it down here. What is this reaction? The reaction involved are shown below. They have already shown, but I'll also explain it. See, this one is a 2-degree amine. It is converted into quaternary ammonium iodide and then moist Ag2O के साथ heat करके Hoffman alkene, least substituted alkene, and a amine is free. Okay, a cyclic amine undergoes Hoffman exhaustive methylation twice to give an amine and a diene. So I have already used a cyclic amine for the process, and one double bond I kept it in advance because it is in context with the question followed. So what they're saying is CH3I. Now see, as the amine itself already is a 3-degree, here it is a 3-degree, so I need only 1 mole of this CH3I and I'll get this position, nitrogen, as a quaternary ammonium iodide. Now why we exchange with moist Ag2O? Because this I minus is a very poor base and the reaction we want to carry out for this heating step is E2, and for E2 you need a strong base. So we replaced this weak base I minus with a strong base OH minus. Then we can heat and cause E2 reaction. So once it is heated, you have to mark quaternary nitrogen ke both sides as alpha and alpha carbons. Mark the next carbons as beta. Why I am showing this to you? It can be used as a shorthand. Once you draw all the possible alphas to the nitrogen, and those which do not have any beta carbon or beta hydrogen are already of no use for our further discussion. Only those carbons which have further beta hydrogens are useful. So these beta hydrogen, then you have to decide whichever is least substituted or more acidic is the one which we want to remove. Several times I have seen people tell this to be a E1 CB, which is wrong. It is an E2 reaction having a Hoffman product. So here, once we have identified both side beta H are same, so what you do, what you practice is you take this beta H, you break that beta H, and from alpha position you remove the nitrogen. That is simple approach to HEM. Okay, from alpha position you remove nitrogen. From beta position you remove hydrogen and form a double bond between alpha and beta. See, I have drawn here with this red and now purple. That is simple thing. This H will go with this OH minus and will be released as water. Nitrogen will become neutral and here it is a 3-degree amine. Now see, this was an open chain, so 3-degree amine was separated. But as it is cyclic, so 3-degree amine site remain here. Now as it is said na, that it will undergo twice, so I have to repeat. Again CH3I will attack and again CH3I will attack on this 3-degree site and we'll have a quaternary ammonium iodide. Same process, moist Ag2 and heat. I mark the alpha. These three methyl alphas are of no use as they do not have beta hydrogen. So this alpha, beta, and removed this hydrogen and got a multiple bond. I got a conjugated system. 1, 2, 3, 4, 5, 6. 135 hexatriene. So on this particular process, they are asking the question. Let's read what are they asking. The question is, compound C does not decolorize bromine. Again, it does not have C double bond C and dissolves in HCl. Matlab, it must be having some basic center. As the nitrogen was there in compound C, then it is not an amide, it has to be amine. C on treatment with concentrated H2SO4 gives J. Hoffman exhaustive methylation of compound J gives 135 cycloheptatriene as one of the products. Now we have to identify the possible structure of C. So let's move to the solution. C is C8H15NO. It does not decolorize bromine water, so no carbon-carbon multiple bond is present in it. It dissolves in HCl, so it must be basic, having amine functional group and not the amide. On reaction with concentrated H2SO4, it undergoes dehydration, forming J. If so, that it forms J, so it must have alcoholic group, and the alcoholic group should be such that it should be having beta hydrogens capable of forming double bond. Hoffman exhaustive methylation of compound J gives 135 cycloheptatriene. See, the ring is not open. So only one ring is there. One either was there and is broken, or there was no such breakage. Let's see. As one double bond was already present, where already present after the reaction with concentrated H2SO4. So the two were formed by HEM reaction, that too in conjugation. So let's see. This is the A option which is given here. This A I have copied and is written like this. So how I have drawn this, you can take any particular point, say 1, 2, 3, 4, 5, 6, 7. So you have to draw a 7-member ring, and then 1 of 4 are connected with nitrogen. That is how I have done. So see, 1, 2, 3, 4, 5, 6, 7. So it is a 7-member ring, and then 1 and 4 are connected with nitrogen. So this is how I have copied all those questions from there. Concentrated H2SO4. So yes, this has a one side possibility of forming a double bond. Here, 4 digit cannot form a double bond, so I cannot form from 4 side a multiple bond. This is correct. Now they are doing HEM. They are taking it twice. So yes, if they'll do it twice, from here nitrogen will go, from here hydrogen will go, so one double bond, and similarly from here nitrogen, and here this position say H and another double bond. So this seems to be correct choice for what is described in the reaction. Moving to B. First, with concentrated H2SO4, I can form either side multiple bond, no issues. Any one side you can form. I have taken this downside, doesn't matter, it is going to be same. Then again using HEM. So first I'll remove this. So conjugation with the existing multiple bond, I will get this H from here. So a double bond. And second time in conjugation, I'll get here. So this again seems to give 135 cycloheptatriene. So it seems to be appropriate. Moving to C subpart, this is our OH. So even if I want to undergo dehydration, this side is the beta H loss or this side, but both are bridgeheads. They cannot undergo dehydration. So my first information itself proves to be wrong. So this cannot be our answer. Moving to D option, you can see that yes, you can remove OH from either side. Again, same story. So I can have, say, from this side, if I remove H from here and OH, so I got this double bond. Again, HEM 2 times we have to do. Alpha say nitrogen and adjacent positions H double bond, and from upper side. So again, we have 135 cycloheptatriene formed. D is part of answer. Moving to E, if I start doing the same thing, I don't think we'll get the answer as after HEM. The problem will be that yes, if you remove nitrogen from here, hydrogen is from bridgehead. Nitrogen from here, hydrogen is from bridgehead. So you cannot remove nitrogen by HEM in this process, and thus we cannot have the required conjugated heptatryne mentioned in the question. So I think this is our 3.4 done. And we have got A, B, and D. These three are our answer. Correct? You also should check the required carbon hydrogen count, though I have already checked, so it is coming correct. Moving to question number 3.5. Compound C on controlled oxidation gives a compound K, which gives a yellow precipitate with 2,4-DNP. This yellow precipitate with 2,4-DNP is a characteristic of aldehyde ketone and also reacts with two equivalents of benzaldehyde in the presence of a base to give dibenzalidine derivative. This particular line is for aldol condensation. They have given dibenzalidine derivative general structure. I will explain it a little further. Just wait. The possible structure of C, out of these, we have to analyze which could be the possible structure. Now, compound C, as we already know, is C8H15NO. And after oxidation, it will lose two hydrogens. So it will become C8H13NO. Compound C on controlled oxidation gives a compound K. So this must be the formula of your compound K. This tells us that there is an alcohol which is oxidized to a carbonyl group. Now, compound K, which gives a yellow precipitate with 2,4-DNP. So this indicates presence of carbonyl group in K, right? We got two informations. Moving further, it is said that K also reacts with two equivalents of benzaldehyde in the presence of a base to give dibenzalidine derivative. Let me tell you what this is. See, the reaction used in the forming dibenzalidine derivative is basically a crossed aldol, in which benzaldehyde is the molecule which do not have alpha hydrogen. So our original compound K must be having alpha hydrogens and dibenzalidine. So we have to do 2 times aldol. So both of its alpha positions must be capable of aldol reaction. Let me exemplify this point having acetone, which has both sides capable of doing aldol condensation. If you remember aldol condensation, and after this hint, it is perfectly all right. See, benzaldehyde, dilute NH heat from this side, I have acetone and benzaldehyde condensation. From this side, here I have done acetone and benzaldehyde condensation. Now, these are the different formulas they have mentioned. And here I have again noted the formula of the C. We have to identify which could be possible C. We know this C has to oxidize to K, and K should have such carbonyl position that two of its side should be capable of aldol condensation. So anyhow, it cannot be an aldehyde, it has to be a ketone. Let us see. If I oxidize this one, so yes, here I will have oxygen. From here I can have aldol, right? But this position is not suitable for aldol, so I think A cannot be our answer. Moving to B, this is correct position. This will be oxidized to ketone. I have one particular alpha position is here, and there are two hydrogen. From here I have another alpha dash. They have two hydrogens, so this seems to be correct. This can form dibenzalidine derivative. Formula I have already verified, C8H15NO hai, so no issues. Moving to this, even if it is oxidized, I don't have any possible position for even single aldol, so this cannot be our answer. Coming to this, again similar to B, this is oxidized and you have two position for alpha hydrogen, aldol condensation. So D is your answer. Here again, one is bridgehead. So this cannot be our answer. Only those in which I have marked within the box are our answers. Answer is B and D. Correct? So this is our 3.5. 3.61 also I would like to discuss. Write the number of chiral atoms in A and B in 3.5. Chiral is having all the 4 positions substituted by different groups. So these 3 I have marked as red will be the chiral centers. So here I will get 3 atoms are chiral in A, and here you have 2 atoms. HBCSE has given 2 set of answers, 3 and 2 for A and B respectively, and 4 and 3 for A and B respectively. I'll prefer to have 3 and 2. Why? Because the nitrogen in these 2 cases are not regarded as chiral due to flipping. Let us continue with answer 3 and 2. So let's close our part 1 of this particular lengthy question discussion here. I hope you are still with me and are watching. So we'll do rest of the questions in the next 2 episodes, 3.6 part 2 onwards. They'll require a little more explanation, so they will be further split into 2 or 3 episodes as per our requirement. Keep watching our videos and do like, share, and subscribe our channel. Thank you.